Alright, so you guys should have taken notes on collisions on Friday. So now we're going to start calculations. And we're going to just focus on inelastic first because they're a little bit simpler. So an inelastic collision is when you have two objects that are moving towards each other and then they collide and they stick together. So they start out as two different masses. Usually it'll be a couple of cars going towards each other that end up tangled in the wreck and they stick together, or it could be two railroad cars that collide and couple and so they stick together, or sometimes it's like putty or something that sticks together. Sometimes they say that it could be a ball that collides and sticks, but no matter what, an inelastic, or it could be a person catching a ball, and usually that person's standing on ice so that they would slide. But no matter what, it's got to be two things that stick together. So our equation, you're going to have the mass of the one object and the velocity of that object, and make sure you have positives and negatives. So if it's two things going towards each other, let's make the right always be positive. If it's cruising to the right, it's going to be a positive velocity. If it's moving to the left, it's going to be a negative velocity. If they're moving in the same direction, you don't need to worry about signs, but always draw a picture so you know what's going on. So anyway, mass 1 and velocity 1, that's for the one object. Mass 2 and velocity 2, that's for the second object. These are momentums. It's the conservation of momentum. That was in your notes. So the momentum of the two objects to start, this side on the left, has to be the same as the momentum after. That can't change. Momentum is always conserved. So that means that in an inelastic collision, they're going to stick together, so now they're one object, technically. So you're going to add the masses together of the two objects, and that's going to be your mass total. And then they'll be cruising at one velocity because they're stuck together. They're going to go at the same velocity, and we'll call that velocity total. So I want to go over a couple examples, and in general, I want you to always draw a picture. I don't have my smartboard right now, so I can't draw a picture. But on your worksheet, I've given you a lot of space for each question. I hope it's enough, and so I want you to draw a picture. A couple of them I actually provided the picture, but you should always have a picture, and be very aware of what's positive and what's negative with your velocities. So this first example, so I'm going to go through this step by step. I know it looks really messy here. So the example, a 2.5 kilogram ball moving at 7.5 meters per second is caught by a 70 kilogram man while the man is standing on ice. So the ice is going to let him slide. How fast will the man/ball combination be moving after the ball is caught by the man? So this is inelastic because he's catching the ball and he's going to become one object with the ball because he's hanging on to that. So given we have mass 1, I'm going to call object 1 is going to be the ball. So mass 1 is 2.5 kilograms. They gave us that. Velocity 1, I'm going to say it's positive 7.5 meters per second. And then the man is going to be object 2. He is 70 kilograms. And his velocity is 0 because he's just standing there. So what I'm looking for is going to be the velocity. It says how fast will it be. And I know both the masses, so I'll be able to plug those in for mass total. So when I go over and plug this in, I wrote my whole equation here. And then I've got mass 1 and velocity 1. I plugged those in. And I made sure it was positive 7.5. Then I plugged in mass 2 and velocity 2. It's nice because it's 0. It's going to cancel out. And then mass total, I put in parentheses, I added them together. You can add it outside the equation. I just wrote it here so that you could see I was adding 2.5 and 70 because it's now one object. And then I'm solving for velocity total over here. And then I just simplified a little bit. 2.5 times 7.5, that's this 18.75. 70 times 0 is 0. And then this 2.5 plus 70, it's 72.5. And then I got rid of the 0. And then you have to divide both sides by the 72.5. So just simplify as much as you can, and then it will look like an F equals ma kind of equation, like our original momentum equations that you guys were really good at. And then make sure you have the right units. So I've got velocity going on, so it's meters per second. Okay, let's look at another example. So this time I have a 1,200 kilogram car traveling north, and I'm going to call north positive in this case. Just assign a direction to be positive and negative. We're going to say left is always negative, but if they say north and south, you can make up your own mind. At 20 meters per second is going to collide with a 1,400 kilogram car traveling south at 22 meters per second. When they collide and entangle, what is the resulting velocity of the wreckage? So I was given all of my variables on the left. So I'm going to call this 1,200 kilogram car, it's going to be object 1. I have the mass, I have the velocity. I called north positive. Then the other car, the one traveling south, is going to be object 2, so it's 1,400 kilograms. And then it's traveling south, so it's negative 22 meters per second. Then I go plug all this stuff in. So I've plugged in my 1,200 and my 20. I made sure to make my 22 negative. And then over here with mass total, I'm going to add the two masses together. And again, you can do this on the side or you can do it in here. So it's 1,200 plus 1,400 because now the two cars are one object. So I go simplify this. So 1,200 times 20 is this 24,000. Then the 1,400 times negative 22, that is my negative 30,800 right here. And I made sure it was negative. I had to include that. And then over here I added the two masses and I got that it was 2,600 kilograms. So then you add the stuff on the left, make sure you have your negatives, so it's negative 6,800. So that means that in the end, my car, or the two cars together, they're going to be cruising south because that car that was traveling south must have had more momentum, so that means that together they're both going to go south now. But so again, you're going to divide just like F equals MA like we did, and you get 2.62 meters per second, and it's negative, but I called that south because I assigned negative south. Okay, next one. This time we're going to solve for something different. So I've got a 5 kilogram ball hits a 75 kilogram man standing at rest on ice. The man catches the ball. How fast does the ball need to be moving in order to send the man off at a speed of 3 meters per second? So we're assuming that he catches it. Well, it says he catches it, but we're going to assume that he hangs on to it. So it's going to be their one object now. So I was given, I'm going to call the ball mass 1. So the ball had mass 5 kilograms, and the velocity, I don't know. That's what I'm solving for. It asked how fast does the ball need to be moving. Then the man is going to be object 2, so he is 75 kilograms, and he was at rest, so 0 meters per second. But this time, I know that V total is going to be 3 meters per second. So I'm not solving for that anymore. I'm going to solve a little bit backwards. So I'm going to go plug everything in. So I plugged in my 5 and V1 I just left because I don't know it. And then plug in everything for the man, object 2. And then M total over here, I'm going to add them together again. I've got the ball plus the man, so altogether it's going to be 80 kilograms. And then V total, this time I know that, so I'm going to plug that in there. And then if you simplify everything, 5 times V1 is just going to stay the same. And then 75 times 0, that's nice, it's just 0. And then I'm going to simplify my 5 plus 75 is 80, and it's still times 3. And then I go simplify a little bit more and get rid of that 0 and then figure out what 80 times 3 is. And it was this 240. So now it looks like F equals MA again, and I'm going to divide by the 5. So I divide 240 by 5, and I get 48 meters per second. And this time I just assigned that the ball was moving in or V total was positive, and so that means that the ball is moving in a positive direction. You can always go with positives unless they're moving in opposite directions. Then you need to take into account negatives. But if it's just one object cruising towards something that's at rest, it's fine to just make it all positive. It makes it simpler. So those are the examples, and there's 9 questions on your worksheet, so always draw a picture. I know I wasn't able to here, but it will help you clarify what is really going on and if they're going towards each other or if they're not, and if one's at rest, it's good to know. And then just plug everything in and simplify.